Hello everyone, welcome to a series of videos on logistic regression. The topics what I would like to cover in this series of videos is migrating from concept of linear regression to logistic regression. What is the loss function in logistic regression, cost function, gradient descent, parameter estimation, and optimization techniques. So this will be a series of videos and each video will be of around 10 minutes. So let's start. And a few things like I assume that or prerequisites to have a good understanding on this series of videos is to have a fair amount of understanding in linear regression, bit of understanding of matrix calculation, and obviously R. I will be using R for in the later part of this videos where I will be checking the loss function, cost function, gradient descent, everything. So let's start. So from linear regression to logistic regression, so how do we migrate? So as we all know that these are the predictive techniques, and so when we have predictive techniques, in another way we know it as a supervised learning also. We have input data. The input data contains the list of individual variables, and then we have one output data which is called dependent variable. And based on the input data, we have to build a model which can predict the dependent variable. So let's assume that the input data what we have, it has m data points with p number of independent variables. So in matrix form, the data input data, let us symbolize this as x, will be a matrix of this shape. Would like to add another point here that we are considering including the bias term also. So though the input data will contain variable from x1 to xp, x1 somewhere here to xp, as we are going to have a bias term, so bias term here is indicated by x0, which will have value of 1 for all the m data points. So the input data what we have with p number of independent variables will be converted to input data set x with the bias term, means value for the bias term, input data for the bias term. So the dimension of the input data will become m rows and p plus 1 number of columns. So we have m rows and p plus 1 number of columns. Next thing is that as we have p plus 1 number of independent variables now, including the bias term, so the parameter what we have to estimate for the predictive model will have p plus 1 parameter. Each independent variable has to have the estimated parameter. So as we have p plus 1 number of independent variables, so we will have p plus 1 number of parameters. Another point, the parameter does not depend on the number of data points. It depends on the independent variable only. So in totality, we will have p plus 1 into 1. This would be the dimension of the parameter matrix. So the dimension of parameter is denoted here with theta. It's a p plus 1 number of rows and 1 number of columns. So that's the dimension of the parameter matrix. Now in linear regression, what we do that for each data point, like first data point, that x1, this first row, is multiplied with the parameters. Then second row is multiplied with the parameters. And that's how we get the predicted estimation, which is generally called Z. So in linear regression, the value of Z is represented something like this. In matrix form, we can represent this as x dot theta. Let us check the dimension. X is of dimension m into p plus 1. So matrix m into p plus 1 is multiplied by another matrix of dimension p plus 1 into 1. So as I said earlier that we should have a bit of basic understanding of matrix operation. So the dimension of Z will be m into 1. So that's how the input data is converted to predicted value. So we have input X, we calculated predicted Z, and this is compared with the Y. Y is the actual output value of the dependent variable. The difference here in between linear regression and logistic regression is, in case of linear regression, the y can vary from minus infinite to plus infinite, but in logistic regression, it varies from between 0 and 1. Now, as I understand that we have a good amount of understanding of linear regression. So, having the understanding of linear regression, how can we proceed? How can we migrate towards the logistic regression concept? So let us do that. So as we know that in linear regression, the Z varies from minus infinite to plus infinite. Now this need to be transformed to the value range from 0 to 1. And that value is, we can tell it as a y hat, or we can term this as a p. For simplicity, let us term this as p. So requirement here, minus infinite to plus infinite to be transformed to 0 to 1. Let us think in another way. Let us proceed in another way. So if p ranges between 0 to 1, then 1 minus p would range from 1 minus 0, that is 1, to 1 minus 1, that is 0. Now if we divide this range by this range, then it would become 0 by 1, which is 0, p by 1 minus p, that is called as odds ratio, and 1 by 0, that is called infinite, undefined. Now let us take logarithm across this term. So log 0 will log of 1 by 1 minus p. In other words, log of the odds ratio would range between log 0 to log infinite. Log 0 is minus infinite, log infinite is infinite. So finally we arrived to this statement. So we started from 0 to, if p varies between 0 to 1, we can say that log of odd ratio will vary from minus infinite to plus infinite. And this seems a bit similar to linear regression, because in linear regression also minus infinite, the z value varies from minus infinite to plus infinite. So there is similarity between this statement and this statement. Thanks for watching. We will continue in the next video from this place. Thanks a lot. Please watch the second video.